Hello everyone, this is Mr. Wolf, and today we are going to be working on converting our improper fractions into mixed numbers. Now, a reminder, an improper fraction is any fraction where our numerator is larger than our denominator, where we have more pieces than it takes to make one whole. That means that any improper fraction is going to have a value greater than 1. So I'm going to look at this number. I have an improper fraction of 12/5. And there's a few ways I can solve this. The first is I'm going to just give myself 12/5. So here I have 12/5. Each of these I'm saying is worth 1/5. And I've got 12 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so now I need to figure out, how can I find my wholes? I want to know how many wholes I have. Well, what I know about denominators is that the denominator tells me how many pieces it takes to make one whole, how many pieces I've broken my whole into. So this tells me I have broken my whole into pieces of 5 equal pieces. So it will take 5 pieces to make one whole. So I'm going to look on to my chart up here, and I'm going to say, oh, okay, I see right here, I have 5/5. And that would be equal to 1 whole. And then I'm going to look, and I see right above it, I have the same little shape of another 5/5, which is another whole. But I don't have enough to make another 5/5. So I'm going to look at this and say, okay, I have 1 whole, 2 wholes. So 1 whole and 1 whole. And I know 1 plus 1 is 2. And then I'm going to look at what didn't get circled, what wasn't used to make my fifths. And I'm going to say, oh, or my wholes. I'm going to say, oh, there's 1/5, 2/5. There's 2 of my fifths left over. And now I figured out that my 12/5 is the same as 2 wholes and 2/5. I'm going to show another way we could do this same problem. So in this attempt, this strategy, I'm once again going to be making my wholes. But instead of starting by drawing and making circles, I'm going to use my fraction bars. I really like using fraction bars. I think they're easy to see and easy to understand. So I want to make 12/5. So I'm going to start with an empty whole. So this is an empty fraction bar. Right now, it's nothing. I need to split it into pieces. I'm going to split it into 5 pieces because I know that that's what my denominator is telling me to do. So I'm going to split it into 5 equal pieces. And this is trying the best I can to make those equal. And you'll notice this is 1/5, this is 1/5, and this is 1/5, and this is 1/5, and this is 1/5, but I haven't filled in any of it yet. I don't have any. I'm right now at 0/5, but I'm going to start filling it in. And I'm going to fill in until I get to 12. So I'm going to start here. I'm going to say, all right, there's 1/5, 2/5, 3/5, 4/5, 5/5. Now I have made myself 1 whole, and I'm going to write that down, that I now have 1 whole. But I'm only at 5/5. I need to get to 12/5. And to do that, I need to give myself another empty fraction bar. And because I'm still working in fifths, I'm still going to cut it into 5 pieces, each of which is worth 1/5. And I'm going to keep going. I had 5/5. Now I have 6/5, 7/5, 8/5, 9/5, 10/5. I still haven't reached 12 yet, but I filled up another bar. That is another hole. And I need to make myself another empty bar. So now here's my third hole, but we're going to notice something. As I split it into my fifths, 1/5, 1/5, 1/5, 1/5, 1/5. I'm trying to get to 12/5. I had been at 10/5. Now I'm at 11/5, 12/5, and I can stop. And so I know immediately, even before I count anything, that my answer is going to be somewhere between 2 and 3, because I filled up 2 holes and I didn't fill in a third hole. What I have is 2/5 filled in. And so I can look at this and say, I have 1, 2, and 2/5. So all of this equals 2 and 2/5. And we can do this exact same thing without drawing the bars and simply using what we know about fractions and wholes. So I'm going to look at this one more time. And I'm going to say, I know that I have 12/5. And I want to look at how many holes I have. And because I'm working in fifths, I know to make one hole, I would need 5/5. And as we always do with my class, once I have a hole written, I'm gonna draw this around it. That means it's 1. This is the exact same thing as being equal to 1 hole. And I'm gonna do some quick mental math. 12 minus 5, well, that's 7. I can fit another 5 in there. So I'm going to do it. Plus 5/5. And that's a hole, so I'm going to put my little box around it. And now I'm going to say 12 minus 5 is 7. 7 minus 5 is 2. I can't fit another hole, so I'm going to write in what I have left over. 2/5. And I can check. I'm going to go backwards now. 2 plus 5 is 7. 7 plus 5 is 12. So that worked. And so now I'm going to change these. These are no longer 5/5. These are just going to be a big 1. And this is going to be a big number 1. And now I have 1 plus 1 is 2, plus 2/5 is 2 and 2/5. Now finally, using this same strategy, we have the last strategy, the last step we can do, which is we can look at this and know our math facts. That I can look at this immediately, and I know 5 fits into 12 2 times. I can count up 5, 10, 15. 15 is too big. And the reason this works is because fractions are division. So I'm going to rewrite this problem a little bit. So I remember that fractions are division. 12/5 is the same thing as 12 divided by 5. And now I can do my division. I look and say, can 5 fit into 1? It can't. Can 5 fit into 12? Yes. Yes, it can. It can fit in 2 times. I'm able to fit 2 wholes into 12. I'm going to say 2 times 5 is 10. 12 minus 10 is 2. And I'm going to check, can I fit my 5 into 2? I can't. And here's the thing. We have a remaining 2 left over. And those remaining 2 are 2 out of the 5 we're looking for. 2 out of 5 is a fraction. 2 out of 5. Or 2 and 2/5. Our remainder becomes the numerator. Our divisor becomes the denominator. So these were 4 different strategies for how to change our improper fractions into mixed numbers. I hope this was helpful, and I'll see you again soon.